Alright. So, whenever we talk about credit risk, it's one important risk for financial institutions. Okay, the other major risks that come into the category, they should be very much careful about the market risk, they should be careful about the operations risk, but of course, the credit risk becomes one of the most important aspects for financial institution. And what we see is they really go with a good number of resources. They invest in manpower, tools for measuring and managing the credit risk. It becomes one of the high priority objectives for a bank to understand how much is the credit risk and come out with the measures and mechanisms to handle the credit risk. Even from the regulator's perspective, right, like the central banks of the country, they keep they always mandate the banks to maintain certain amount of capital which would be in line with the kind of credit risk that they are taking. So there is a kind of a backup. Regulators always are stressing that the banks need to have sufficient backup associated with the kind of credit risk that they are taking. And whenever we talk about credit risk, there are two major dimensions that come up. The borrowers, bank is a major lender, right? So there is a possibility that the borrowers, in case of lending process, and counterparties, in case of a derivatives transaction, they default. And whenever they are defaulting, the parties which are on the other side, like the lender in case of the lending operation, or the bank in case of a counterparty, they are typically exposed to a risk, and that risk is what we are calling as the credit risk. Now, to assess the credit worthiness of the companies and the corporate bonds, there are what are called as a credit ratings which are given by companies like Moody's, S&P, Fitch. Moody's give a rating like this: A, AAA kind of stuff, AA, A, BAA, BA, B. And even within this, let's say right from the second grade till the last but one grade, or even the last grade, what they do is they have given something like AA1, AA2, AA3. Just again, in subdivision internally. Similarly, A1, A2, A3. BAA1, BAA2, BAA3. So some kind of a subgrading also they have given. And any bond with a AAA or AAA rating are considered to be more or less secured, no chance of defaulting. And anything that is above this, only these bonds are called as investment grade bonds, and these are called as speculation grade bonds, right? I can call as speculation grade bonds, or sometimes we call them as junk bonds. And so the same thing goes with S&P and Fitch. So up to here they are investment grade, I can map them one on one, and up to here they are speculative grade. And just like this 1, 2, 3 notation, here we have like AA plus, AA and AA minus, A plus, A minus, triple B plus, triple B, triple B minus. This is the kind of a subcategorization which S&P and Fitch give, which is more or less mapped on similar lines with that of Moody's. Only the highest and the lowest subcategories. So this is not graded, subdivided, and probably here we don't see this being subdivided. So that's how the credit ratings give a first-hand information with respect to the credit worthiness of the bonds as well as the company per se. Then, now let's start looking at the historical default probabilities. Historically, the statistics collected regarding the default of the investment grade bonds and the speculative grade bonds. What has been observed is when I look at the investment grade bonds and I am looking at the probability of default in a year, right? So if I take the time period here and probability of default here, it looks like it's an increasing function of time. Means initially the probability of default could be much smaller, but as the time is increasing, the probability of default is increasing. Why? Initially, it's a good company. It is credit worthy. So today the probability of default is lesser. But as the time is elapsing more and more, there is a good chance that the performance of the company may deteriorate, and because of that, the financial health can decline, which will increase the chances of default of that particular kind of company. Whereas on the other side, when I look at a company with already a poor credit rating today, what matters is now. The criticality is to now and the next year or two. So what is typically seen is the probability of default, we are seeing it as a decreasing function of time. Because if it defaults, yes, it should default in the next year or two. But if it does not default and it has survived the initial couple of years, there is a good chance that its financial situation is improving. Otherwise, it would have defaulted by now. So, historically, by looking at the data, this kind of conclusion can very well be made. So, these kind of information has been dug out from the historical data. Then, hazard rate. If I have to introduce the word hazard rate, generally represented by lambda t, it is simply selected in such a way that lambda t times the delta t, which is the time period, which talks about the probability of default of a particular company or a bond between time period t and delta t, which means during the small time period delta t, we are talking about the probability of default. Based on that, we are computing this lambda t, and this is conditional on no earlier default. Right? Assuming that the default has not occurred earlier, we are trying to find out what is the possibility that the default will occur between the time period t and t plus delta t. That is what we are calling as the hazard rate. And whenever we are using the word unconditional default probability in the nth period, I am always looking at what is the probability of default by the end of the n period minus what is the probability of default by the end of n minus 1 period. The difference between the two is going to give me the probability of default in the nth period. And a few more interesting equations. If I am looking at a variable called v of t, and if I am defining as cumulative probability that a company will survive up to time t, so the default between the time t and t plus delta t, it is like, okay, surviving up to time t is v plus t, v of t. Surviving up to t plus delta t is v of t plus delta t. The difference between the two is what it has defaulted between time t and t plus delta t upon the original, which is what is the v of t. This is what we compute as the probability of default between t and delta t. But at the same time, we said the probability of default between t and delta t, we already said that it is equivalent. We already said that it is equivalent. If you remember, the delta of t comma delta of t lambda of t times delta t, we already said it as the probability of default. So I'm looking at the change in value v of t plus delta t minus v of t. So because of that, I can equate this to minus lambda t delta t, or lambda t delta t is equal to v of t minus v of t plus delta t by v of t. So from here I can get v of t plus delta t minus v of t is equal to minus lambda t delta t vt. And now I can very well define q of t as the probability of default by time t. So this is the probability of survival. So by the time t, if it has to default, then it is 1 minus of e to the power 0 to t. I'm looking at the hazard rate, lambda of tau d tau. So from here I am very much getting that q of t is 1 minus e power minus lambda, the average hazard rate times t. And this hazard rate is also being called as a default intensity. So I can very well find out the average hazard rate between time 0 to t, from where I can be able to compute the default probability by the time t or between two time periods. All kinds of calculations can comfortably be done.